Hello, and welcome aboard on our behalf and that of Data Mining Class 1066. Now, if you will just follow along with me, we will be on our way. Welcome aboard. Before we depart, there are some important things we will tell you. Our first priority will be to present what the decision trees and the Bayesian networks are to our classmates and the whole crew. For this first part, we will tell you about decision trees in machine learning and data mining. So we will introduce them and then we are going to guide you through their basic algorithm. Disaggregation in leaf nodes, as well as in ID3. Search and overfitting, and finally, over control of size. Tree-based classification methods are frequent in statistics and pattern recognition. Especially in botany and medical diagnosis. This is partly thanks to the understandable that it manages to be, so some people tend to trust more in them than in other methods. About the hierarchical data partitioning, we can say that a classification tree divides the space on which the learning units in sub-regions are defined. So for the construction of these trees, each one must make them grow from the root. In the case there is an exact partition of the data, the construction of the tree is very simple. But, if it does not exist, we might have overlapping parts in the partition and that could become a problem of overlearning. In that scenario, we could solve this problem in two ways. The first is to stop growing the tree before it is fully developed. Or by the second, to prune the tree once it has been completely built. Now, let's review the Bayesian networks. Please pay close attention to one of the most popular prediction models, also known as belief networks. Bayesian networks model a phenomenon through a set of variables and the dependency relationships between them. Given this model, the posterior probability of the unknown variables can be estimated based on the known variables. These models can have different applications, for classification, prediction, diagnosis, and others. In the areas where its application has been successful are economy, medical diagnosis, industrial diagnosis of power plants, and even have gone into areas such as bioinformatics and quality measurement. As well, you will find implementations in prevention of customer abandonment, money laundering, personalized marketing, customer scoring and classification of stellar data. Thanks to the fact that in recent years various techniques have been developed to learn from data, both the structure and the parameters associated with the model, it is possible to build them without having done them by hand. About the reasons that have led to the use of these models has become popular, in addition to that development and how intuitive it can become their interpretation, is that the theories on which they are based, that are the theory of probability and the theory of graphs, are well studied and grounded. Thus, a Bayesian network by definition is a directed acyclic graph in which the nodes represent random variables and the arcs represent relationships of direct dependence between the variables, and that complies with having a joint probability distribution that satisfies each variable is conditionally independent of the set of their non-descendants given the set of their parents. In a brief way, without making you dizzy, we can say that a Bayesian network is a structure to represent a joint probability distribution of a brief, concise and prescient form. Creating a Bayesian network, without the help of computational techniques, can be a laborious and especially complicated task when dealing with large networks. Therefore, methods were developed to learn both structure and conditional probabilities from data. These methods of network learning generally occur in two phases: structural learning and parametric learning. For structural learning, the objective is to obtain a directed acyclic graph that represents the model and its dependencies, while the parametric learning consists of obtaining the conditional probability tables for each node. These tables represent the probabilities of each state of that node given the values of the parents. Some examples of structural learning algorithms are the algorithm of Chow and Liu, the algorithm K2, the max-min hill climbing algorithm, and the max-min ant colony optimization algorithm. For parametric learning algorithms, we can find expectation maximization algorithm, probability propagation algorithm, etc. In practice, in many cases the data is not complete. There are two basic types of incomplete information. There are missing values, which means that some values of one of the variables are missing in some cases. And the hidden nodes, what stands for the case when all the values of a variable are missing. When there are missing values, which is the simplest case, there are several alternatives, among them. Delete cases records where missing values appear. Consider a new additional value for the variable, such as unknown. It will take the most probable average value of the variable. Consider the most probable value based on the other variables. Consider the probability of the different values based on the other variables. The first two alternatives may be appropriate when you have a lot of data, but if not, in a certain way information is being wasted. The third alternative does not consider the other variables of the model, so it usually does not give the best results. The fourth and fifth alternatives are the most interesting and in general the best. So there may be a way where it can be possible to do some adjustments to your data, so they may adequately fit in the model of the Bayesian network. Now, we are pleased to show you what you might be expecting to hear from this talk. Bayesian networks real implementations. For December 2013 in Mexico, a project was developed which dealt with a global health problem and which ranks first as a cause, due to cancer, of death among women. Breast cancer. For the classification analysis of this work, we used a subset of 58 images from the public database Mammographic Image Analysis Society. 67 descriptors of location, intensity, shape, and texture were extracted. This set of characteristics was selected considering the medical literature and works related to the classification of masses. The paper presents a comparison of the performance of models of the naive Bayes type, naive Bayes increased to tree-tan, K-dependent Bayesian classifier KDB, and naive Bayes increased to forest fan, where experimental results show that certain models achieve a performance of 0.81 in accuracy, 0.65 in sensitivity, and 0.89 in specificity. Therefore, it is considered that these models, which allow dependencies between variables, are adequate and promising for automated mass classification. On the other hand, when talking about the quality of a piece, it is often associated with its appearance and physical appearance. However, this can be misleading in the sense that the surface may contain characteristics that are not reflected in its appearance. Behind the appearance, a machined surface may contain imperfections and deviations from the expected nominal surface that compromise the quality of the piece, hence the need to clarify what the measurement of surface roughness refers to. Therefore, it has been possible to develop two models for surface quality prediction using Bayesian networks, tree-augmented network, and neural networks multi-layer perceptron, in particular surface roughness, in a high-speed milling process using classical variables as tool characteristics, cutting parameters and process variables, and including other new ones in this environment such as material hardness and geometry of the piece to be machined. Good precision results were obtained in both models, although the superiority of the Bayesian networks is demonstrated not only in the goodness of the classifier but mainly in its interpretability. And for the last part, using Bayesian networks for the fraud detection is rather reasonable because of the possibility to automate decision and training processes, clarity of these processes, and simplicity of calculations in comparison with similar decisions. For this project was required to have real legal and fraud transactions. The number of credit card fraud cases is permanently increasing. Therefore, at this moment the problem of fraud prevention system implementation with automatic decision-maker functions is really actual.
The crew will now be coming around to do a final cabin check. After takeoff, we'll be back with more information. And if you need anything, don't hesitate to ask. As always, we're here to make your flight great. Because great is what we're going for.